Yeah, drop, hey, huh.
Yo, what's up guys, this is 𝗪𝗘𝗟𝗟𝗟 and today we're playing babygame03 from PicoCTF, another Binary Exploitation challenge. If you haven't seen my previous videos on babygame1 and babygame2, I highly suggest you see them before you proceed with this write-up. I will leave them in the description below. So let's start. We download the files right here and we see we have just the game. Flag is just a template I made, and I also made a template solver here. And let's see, we run the program. The old reliable map.
Old reliable.
And again we see we can move with WASD. But right now we see that we have lives left, and every time we move or we insert some random character, we see that the lives decrease. We see also we have levels. Right now we are at level 1. And also we see right here we have something like an obstacle. Okay, let's go left. No more lives left, game over. And what happens if I go right here? You hit an obstacle and the program crashed. Enough fuzzing around, let's go inside 𝗙𝗢𝗟𝗟𝗪. So we're right here, again we have our map, and then our position, X and Y. We continue, we see we have level and a counter, init map, init player, print map, same as the previous challenge. And the new thing is here, we see that if our position X is this and position Y is this and level is not 4, then you win. Next level starting, increases the counter, increases the level, and rearranges the position as we know them. And this loop continues until we are not at the end and the level is not 5 and the counter is not 4. Okay, so our goal here is we are in the last tile right here. We are at level 5 and the counter is not 4. And after that it calls win with level, and we see it opens flag, and it will only print it if level is 5. So our goal right here is to reach level 5 with counter having the 5 value also. And let's see how we can achieve that inside the debugger. And let's see, let's have a breakpoint at move player, and then we run. If you remember from the previous challenges, if we insert L and something like I, it will just change the tile to whatever we want. So Li to have the value 69, and we are inside move player, continue. And right here we see we have our grid, the map. So I'm gonna do, I don't know, something like xgx this minus 0x100. Okay, we see we have the grid here, and our tile is right here, 69. And also we have some other values above. And like the previous challenges, this challenge also has an out of bounds vulnerability. But in our case here we see that inside the map we have a 23 value that if we hit, this is our obstacle, so the program will exit if we hit this address. And right here we have some other stuff. Let's see what we can possibly abuse. First of all, Disassemble. So right here at the bottom we see that it calls win. This is the last check it does at 391. And right here above we see that it adds 1 to something right here, add 1 here and 1 here. So this is actually our level and this is our counter, or the other way around, I don't remember exactly. And also if we continue inside move player, let's see what the return address is. So right here we see that the return address is this value. When the move player returns, it will go to this address, which is main 187. And let's write them down. So I have made this template so far, and we know that our initial position is this. If we run the program again, let's say li, continue, and right here we see our 69 is this, xc, this address. We see that this is actually our I. That's nice, so we know the position we land in the first place. And we also know that the return address is this. So If we try here and search for it, you will see that it starts from here and continues until this. So this is actually the return. You see 08 and then 0499 which is exactly this address we want, and its offset lies here. We can also check that like this. We see that we have the 44, which in hex is 0x2c, so this is actually the last byte that we want to change. And also again inside the main we saw that the last comparison, we can also see it from 𝗙𝗓𝗟 again, we actually want to keep this comparison and go right here to start increasing our counter, and this last comparison lies right here. So we also have this address, which I call 𝗪𝗘𝗟𝗟𝗪, that ends with FE. So what we have so far is that we know our initial position, we know the address of win that we want to call after we hit level 5. We also know where we want to hit in order to increase our level and counter before the program hits a comparison or something. And we also know that the return address of move player lies right here. So what we're gonna do, we actually want to create a sequence that will jump right here, right at this byte, and it will overwrite it with something. First we need to overwrite it with 7F, so we skip every comparison and just increase our level and our counter. After 4 runs we should change it to FE, so it will call win, the level will already be 5, and we will successfully call win and print the flag. So let's create our sequence here, def, let's say sequence, that's gonna take our offset and the byte we want to overwrite, and our moves should be something like, first of all, let's start with an empty string, and after that, as I said here, we cannot simply go back because we will hit this 23 right here, so we actually need to find an address in here that when we jump, when we press W, it will land exactly at 2C here. And if you don't remember from the previous challenge, A just moves us 1 byte left, D 1 byte to the right, but W and S moves us 90 bytes, 0x5A, and we can either try manually and find the address we want, but I'm just a lazy dog, so I'm gonna do it like this. So first we need to find our W's right here. So we have this times, and we want the offset from where we are to where we want to land. So it's gonna be offset minus 0x5a, which is how many bytes W increases every time we press it. And after that we want to find our D's. So we have D times, and right here we have 0x5a, because let's say our offset is 415, the max value of W's is 4, so 4 times 90 is 360, the remainder is 55, so we want to do something like 90 minus 55 to find our D's, and that's the second time I'm saying D's without the usual meme, so take it.
These nuts. Got him!
And after this hilarious break, we have found that these we want are 35, but let's do it manually. So we want this minus len of the current moves we have, actually offset minus len moves times 0x5a. And after that we continue and we want to add the byte. Every time we want to overwrite either the increment counter or the 𝗪𝗘𝗟𝗟𝗪. And last but not least, we have our last W that will jump right to this byte, and then return moves. So how we're gonna abuse that? First of all, print, let's say, sequence offset and byte, let's say \x7f, so something like this. Also right here we forgot we want L, so we change it to the byte we want, and let's print our sequence, Python solver. So the sequence will be something like that, and we saw that the offset is also 415. So let's craft our payload right now. We have reached level 4, so the payload should be something like sequence of offset, and the byte we want this time is 0x7f, and we want this 4 times for the first 4 levels. And after that we want to overwrite the return address with win, so payload plus equal, and we want sequence offset and \x fe. So if we send the payload r.sendLine payload, hopefully this should give us the flag, and boom, we see GG easy, we finally got the flag.
Yeah, bitch! Magnets! Oh!
Let's also try and test it remotely. So we open a remote instance, it's right here. So let's see if this works remotely. And we got part of the flag. Meh, let's try and see. Let's hope only the last one is missing. And yeah, we finally managed to solve the challenge. Why are the forensics right here? Never mind. So that was the challenge, guys. I hope you found the video useful and helpful. If so, leave a like and subscribe to the channel to support me. Have fun and see you in the next video. Bye.